Hello everyone, today we're going to learn chapter 3. Chapter 3 will be divided into 3 parts. So for today we're going to at least try to complete a certain part of chapter 3.1. Okay, so in this chapter you will learn about all of these. For me, I prefer to explain what all of this means in its designated slides. Okay. So in this chapter you will learn more into depth about tangent line and rate of change. I'm sure you have come across into this kind of information before, but in this chapter we're going to learn into depth. Okay, first, what is a secant line? Secant line is a straight line joining 2 points of a function. Okay, so here you can see secant line is the red one here, 2 points, which is at point A and point A plus H. It is a line that joining 2 points of a function. It is also can be known as average rate of change, or simply the slope between 2 points. So this is its other name, average other name for secant line, which is average rate of change or slope. Okay, for slope, how to find slope is by using this equation, which is FA plus H minus FA plus over H. Okay, how can we get this equation? I will show it to you now. Oh, sorry. Okay. Okay, let's see. Let name here. A here is P1 and this one here is P2. Okay, so for P1 is A and FA. Okay, similar, FA is also known as Y or FX. You have come across this before, but since we are concentrating into A, so we use FA instead of FX. So for P2, it should be and FA plus H. Okay, P1 can also be known as what, guys? X1 and Y1, and P2 is X2 and Y2. So to find M or slope for this, okay, I'm sure you have learned this in secondary school before. So to find M is Y2 minus Y1 or over X2 minus X1. Okay, this can also be written as F A plus H minus F A Y1 over A plus H X2 minus, what is X1? A. So now you know where it got this h here. Okay, class? So for tangent line, tangent line use basically the same equation except with the addition of this limit function. Okay, the equation for tangent line is the same as secant line, but it has the addition of limit function here. So you can either use limit h as it approaches 0, or use limit as x approaches a, depending on the question. Okay, first let we recap what is a tangent line. Tangent line is a straight line that touches a function at only one point. Straight line that touches a function at only one point. So the point here is A, only one point. Whereas for secant line, it is a straight line that joining 2 points. So I hope you can differentiate what is secant line and tangent line. Tangent line can also be known as the instantaneous rate of change. I'm not sure whether you can see this or not, but tangent line can also be known as instantaneous rate of change. Okay, so now let's move on to the next slide. Okay, so the dotted green line here is the secant line. What is a secant line again? It is a straight line that join 2 dots on a function. So for this first line here, it join a function. It join point P and what class and Q1. So for L2, P and L2, P and Q2, P and Q2. Okay, so for this line, it might look like Q3 share the same line, but it's not. It is just P and Q2. So for L3, it is P and Q3. Okay, so so the length between P and Q1 is H plus X plus H1. Q2 is X plus H2, and QT is X plus H3. So from this line, this red line is what, guys? It is a tangent line. So for this tangent line, which point touches it? It is just P. We are just looking at P. So it is only 1 point. Okay. So now let's look at the examples. Okay. So let's look at the first question. Let y equals to x squared plus 1. So first question asks us to find the average rate of change of y with respect to x over the interval 3 to 5. So what does it mean here? Okay, the interval 3 to 5 is the domain of the value of y that you must find in the domain of x between 3 and 5. Okay, that what it means by the interval. You must find the value of y in between x value 3 to 5. Okay, so first find y1 when x equal to 3. So y1 is x square plus 1. So 3 square plus 1 is 10. And now we try to find y2 when x equal to 5. 5 square plus 1 is 26. Okay. Okay, so now we have 2 points, which is what class? Can anyone guess? 3. When x is 3, y is 10, and 5 and 26. 26. So this enable us to find the average of change. Okay, only now can we calculate the average of change. Average of change can also be known as what? Class, average of change is m. Okay, or slope. So how to find it? M is y2 minus y1 and x2 minus x1. So it should be 26 minus 10. I don't know what happened here. Okay, let me try to do it here. Okay, 26 minus 10 and 5 minus 3, you get 16 over 2, and then you get the final answer should be 8. Okay, so now let's look at question 1b. Okay, so for question 1b, this question wants us to find the instantaneous rate of change. Instantaneous means what, class? It means tangent line. Okay, so we want to find the tangent line when x is equal to -4. So let's draw the graph here. The graph is x square plus 1, so it is a parabola graph. Okay, and we are trying to find the value at this point when x equal to -4. So we want to find the value of the point when the curve x square plus 1 touches when x is -4. Okay, so how to find it? Let's look at the... Okay, so now we must use either this equation or this. So which one should we use? Since we know the value of x is -4, so we should use this instead of this one, because this is as h approaches 0. Okay, so we're going to use this equation. So let's go back to here, and then let's see, let's try it here. So limit as x approaches what class? -4, and then fx minus fa, right? Let's see, fx minus fa over x minus a kan? So, sorry. Okay. Okay, fa is f -4 over x minus a, x minus -4. So we do it on the side here. What is f -4? It okay, remember again, x is x squared plus 1. So in this case it should be -4 squared plus 1, and you will get 17. Okay, so limit 4 and x squared plus 1, sorry, I can do it here, so okay, so we're going to do it here. X squared plus 1 minus 17, and then x plus 4. Okay, if we try to substitute -4 here, at this point you will get 0 over 0. So this is unacceptable in the limit world. So you have to manipulate this equation, so the answer won't be 0 over 0. So how to manipulate it? Okay, now you can do the algorithm here. So minus 17 plus 1 is minus 16. So x squared minus 16 and x plus 4. So now as you see this equation, can you manipulate it? Of course you can. So x and x plus 4. Okay. So now the equation should be x minus 4. So now you can substitute x with -4, -4, sorry, I don't know what happened. Okay, and then you will get -8. So this is the final answer for question 1b. So now we're going to find the answer for question 1c. So for question 1c, it wants us to find the instantaneous rate of change of y with respect to x at the general point corresponding to x equal to x naught. I don't know whether you can see this or not. Let's see. Oh, sorry. Okay, class. So now let's try to find question 1c. Okay, instantaneous rate of change of y with respect to x at general point corresponding to x equal to x naught. So for this kind of question, sorry. Okay, class. So we have to look back. What the original question here is, let y equal to x squared plus 1, which y can also be known as fx. So for fx node, what can we do to manipulate it? Just substitute x with x naught. So x naught square plus 1. Instantaneous rate of change, you must use the equation to find m, but include the limit. Okay, so the limit here is from as x approaches x naught. Okay, so fx minus fx naught over x minus x naught. Okay, so now we do it here. We continue here. At limit x as it approaches x naught. So fx is x squared plus 1 minus x naught square plus 1 over x minus x naught. Okay, so now what will become of this equation? And then this will be x squared plus 1 minus x naught square minus 1. So 1 minus 1, and then you will get it like this. Okay, so now x square minus x naught square over x minus x naught. Okay, if we substitute x naught right away, we will get substitute x naught into x. Right away, we will get x naught square minus x naught square, x naught minus x naught. It will be 0 over 0. So when this situation happens, we must use the L'Hopital rule. If you remember L'Hopital rule, which we have learned in chapter 2. Okay, you might want to go back to chapter 2 in this particular part, L'Hopital rule. When can we use it, and to refresh your memory. So when it is 0 over 0, we can use the L'Hopital rule. Okay, in L'Hopital rule. Okay, so in L'Hopital rule, we must differentiate. We must only differentiate on the value of an element that contains x. So for this instance, the x naught is not considered as x. Okay, so in this part, it is only here that we must consider to differentiate. So it should be 2x over 1. Okay, now only can you put in the value of x naught. So the final answer is 2x naught. 2x naught. Okay, so m is 2x naught. Okay, so now let's look at the final question 1D, we're going to focus on question 2 actually. Okay, so for question D, find the slope of the graph at the point 2 and 5 and use it to find the equation of the tangent line to this at x equal to 2. So now you know x this at the okay, here we have learned, okay, this is a general point corresponding to x2 x0. So here we can declare 2, 5 is any general point in y equal to x squared plus 1. So it should be x0 and y0. Okay, so to find the slope here is easy since we have used the to calculate it here. So 2x0 is 2 times 2 is 4. Okay, so now I'm going to, okay, so this is the, okay, this is y, and now we're going to find it when it is at x equal to 2. Okay, so how to find the slope? Okay, the equation for straight line is this. Okay, equal to mx minus x1. Okay, remember guys? So y 5 and x. Okay, so this is the final answer. Okay, if you have any trouble understanding any parts in of my lecture, you can always ask me. And yeah, okay, bye guys.